Hello guys, today we will be solving the problems on molality and normality basically. So as we know, our homework for last day was for solving problem number 81 to 92. Many of you have given me the homework by WhatsApping me. Thank you for doing that. I am happy that you have WhatsApped me so many solutions and you have done many good problems in a very short amount of time. Only thing that I want to say today is basically I always suggest people to do KL first and after that go for higher level books. So today I have lost quite amount of faith on KL. I respect KL a lot, but my respect was from 2003. Today being 2018. The main thing that has changed is KL has given solutions of their follow-up problems in the back of their chapter, and many of you did copy from that without even understanding why and how they have done it. It was just complete copy because you sent me so neat solutions that it was very easy to find out that it was copied from somewhere. I won't say that you shouldn't do that. I would blame it on KL because Mr. KL has really taken out the essence of the problem solving from his book by doing this. Because when the problems are given in a chemistry book or a physics book or a mathematics book, the basic intention is to increase the problem solving capability and ability of a student. But when you give the solutions to them, it is very much imperative that people will go for the solutions if they are finding some ready-made. आज के दिन में कितना कपड़ा सिल के कितना कपड़ा लोग सिलवा के पहनता है, सब तो रेडीमेड मिल जाता है. The basic problem is when you get ready-made things, you tend to avoid the reasoning behind that. You tend to avoid how that ready-made thing is coming. Whether be it the kapra, makan or roti, isn't it? People are going for these bread shops all over the country. They are going only to the shops nowadays. Many people don't know how to even make a bread in their home as there are shops because they are getting it ready-made from somewhere. I don't have any problem with that. Somebody is earning. But while you are doing physics, chemistry and mathematics 11 and 12 and you are getting a ready-made solution, my dear friend, problems in life won't be ready-made. Problems in life won't be common from any books. Problems in life won't be type common from any book. The real problems will come all of a sudden to your face, and only those who can face it, who have the real problem solving capacity developed over years from the student life. So on this eve of Independence Day, I would say you one thing very clearly. You will see many patriotic songs that are going all over the roads, all over the places, patriotic movies played on the television, patriotic movies getting released tomorrow or I guess today because it's already 12 o'clock. More than that, I don't know what's exactly the time now right now. But only thing that I want to say, this is not patriotic. If you think that you want to do something for the country, each and every equation you learn, each and everything that you are learning at this moment, you can use those things to help your country to reach a level of higher technical competence, of higher power. It's very easy to fire a gun, but it's not easy to make a gun. It's very easy to buy an iPhone, but it was not easy for Mr. Jobs to visualize this idea of an iPhone. It looks very flashy over an iPad. Oh, that guy has an iPad. It's a great thing. But it's not great. That guy has an iPad. The person who has visualized the iPad, please go through the movie called Steve. There is a movie on Steve Jobs by Ashton Kutcher. Go through that movie. You may learn a lot of things from that. People who fight, people who give their everything, people who give time, midnight oils to that, they succeed. in life. People who go for ready-made solution never succeed on a longer run. You may succeed for a short time. I don't disagree, but in a longer run you will not. That's what I wanted to say. So in this eve of Independence Day, I would like to say one thing. If you really love your country, learn each and every equation that is put forward to you, because that's what you are doing right now. Learn each and every mathematics. Do it. Give your sweat, give your blood for solving that amount of mathematics. That may help you in achieving a higher capability of problem solving skills, which will help you to solve many problems of your country, which will help you to reduce the net account deficit of your country, and which will help you definitely to enhance the GDP of your country. Okay, those are economic terms. But each of those terms are related with what equations you learn right now and how you use it. Even if you want to make some acids, you need some volumetric analysis. You get that muriatic acid in the shop that is written as N by 10, normal, 0.1 normal. You are learning it here, my dear friend, nowhere else. It is 0.1 normal, 15 milliliter. You love your country, don't watch movies. Don't play patriotic songs. You love your country, love your subject. Use that to help your country. You are not the army. If you are going to join the army, that's a separate thing altogether. If you are not going to join the army, please do not say I love the army. You must love the army. You must respect the army. That is fine with me. I also love the army. But I am not an army man, my grandfather was. I am not an army man. My grandfather was. Similarly, if you have chosen the path of science, if you are choosing to go for IIT JEE, if you are choosing to be a doctor, learn every equations. Sometimes maybe you require to make a little bit of acid, little bit of base. You depend on someone else. That is not correct. Each and every of these equations are forming some building blocks of your foundation. Be it physics, mathematics, chemistry, biology. Learn it carefully. If you really love your country, then learn it carefully. Copying won't help. Copying will never help. It hasn't helped anyone. It hasn't helped anyone. And copying without knowing the fundamentals is disastrous. Okay guys, that was the message for the Independence Day combined with the volumetric analysis from my side. Now coming back to problem number 83, it was said that 0.183 gram of monobasic acid is required to neutralize 15 milliliter of N by 10 NaOH solution. What was given in this problem? The problem has two parameters that are very important, N by 10 and 15 milliliter. So I have just written N is equal to 0.1 because N by 10 means 1 by 10 normal. So this is 0.1 and V is equal to 15 milliliter. I just converted it into liters. Now we have already learned in our previous class, the offline class we had this Sunday, that what is the formula of normality? Normality formula is NEQ by V. This NEQ is number of equivalents and this is volume in liters. Number of equivalents. What does number of equivalent means? Mass by equivalent mass. Remember what was number of moles? Mass by molecular mass. Similarly, number of equivalent is mass by equivalent mass. Anyway, first of all I would like to draw your attention in the normality equation. Normality is equal to number of equivalents by volume. That is normality. And the volume shall be in liters. Now from this I can easily calculate number of equivalents. As for NaOH I know what is the normality and I know what is the volume. So I have calculated the number of equivalents N into V and I have found out 15 into 10 to the power minus 4. That is for NaOH. Now last class I have already discussed that for any neutralization reaction, for complete neutralization, number of equivalents of base and number of equivalents of acid shall be same. It won't be different. So here you can see this is the number of equivalent of the base that we have found, and it has been said how this amount of monobasic acid is required to neutralize this amount of NaOH. So NaOH has number of equivalents of this. So number of equivalents of the acid required to neutralize this equivalent of NaOH will be same. So the number of equivalents of acid required is also same. So for acid, number of equivalents required is 15 into 10 to the power minus 4. Now here number of equivalents is equal to mass by equivalent mass or weight by equivalent weight. So I have written 15 into 10 to the power minus 4 is equal to weight by equivalent weight. Now weight of this acid is given 0.83 gram, 0.183 gram, sorry 0.183 gram. So I put 0.183 gram and I have calculated the equivalent weight from this equation. I have got the equivalent weight as 122 gram. Now what has been said to find out molecular mass? Now what is molecular weight and what is equivalent weight? Equivalent weight is equal to, for an acid, molecular weight by basicity of the acid. Now basicity is given over here, monobasic. So it will be, basicity will be 1. So if the basicity over here is 1, equivalent weight will be equal to molecular weight. So equivalent weight we have calculated 122 grams. So molecular weight also will be 122 grams. So this was a very easy problem. Only if you know one concept. The concept is number of equivalents of acid will be equal to number of equivalents of base if there is complete neutralization. So for in case of complete neutralization, number of equivalents of acid will be always equal to the number of equivalents of base. So sometimes in books you will see that they are using an equation called N1V1 is equal to N2V2. So what is N1V1? If you see this one, N into V, this is number of equivalents. So basically they are using the same formula. So if you directly use the formula N1V1 is equal to N2V2 without understanding that what is the meaning of N1V1 and N2V2, then it is wrong. So that is why I did not use N1V1 is equal to N2V2. I have calculated the number of equivalents. And number of equivalents will always be same. That we have proved in the last class. Okay, our next problem is calculate normality. Here it is given, this is for H2SO4. So here it is given as 0.098 gram per milliliter. This looks like a density, gram per milliliter. Now for normality, I have to calculate normality. So we have to first know what is the formula of normality, that's it. So let's see what is the formula of normality over here. Normality is equal to number of equivalents by volume in liters. That's what we want. Now what is number of equivalents? That also we know. Mass by equivalent mass by volume in liters. Okay, so volume in liters I have written like this. Now the thing is that when I see this one, I feel that I require mass, I require equivalent weight, and I require volume, but nothing is given. It is given 0.098 gram per milliliter. So this kind of things generally confuses any person when they do the problem for the first time. But what I feel is this kind of thing shouldn't confuse a person who have done their class 9 physics very crystal clear. Because they should have some information of these units. They should get the idea from this unit only. This unit has everything that is required over here. Now what you require over here? First of all, you say what you require over here. You require the mass and you require the volume in liters. Basically mass and volume, that's what you require. Now what is the mass? So mass is given, some gram is given means some mass is given. And some milliliter is given means some volume is given. So basically something is given over here that you can understand but you cannot comprehend what to take out of that given thing. So let us find out how can we decipher this gram per milliliter. So I will write it over here 0.098 gram per milliliter. That is what is given to me. In this case also I have got some solutions WhatsApp to me, which is copied from Kielchuk solution. I bet they have not understood how it has to be done and how it was done in Kielchuk, because that was hint. Kielchuk hasn't solved it completely, that was just a hint and you just copied it. It's fine. I blame it on Kielchuk, not on you, because Kielchuk shouldn't have given solutions. Okay, so what is given is this one. So I will write it this way: 0.098 gram per milliliter. What does this mean? This means 1 milliliter has 0.098 gram. So I can now write mass is 0.098 gram and volume is 1 milliliter. But volume हमको किसमें चाहिए? We require the volume in liters, not in milliliter. So I will write 1 into 10 to the power minus 3 liter. So let it be like this. Now see, I have got the mass and I have the volume. How I have deciphered this? Just simple unit analysis, nothing else. So now I will put in place of mass, I can put 0.098 gram equivalent mass I need. I have not calculated equivalent mass yet. So I have to calculate now equivalent mass. So what is equivalent mass of H2SO4? First of all, we have to know the molecular weight of H2SO4. So if you calculate 2 into 1 plus 32 plus 64, so it will come to 98 grams. Okay. Now how do you calculate the equivalent weight of H2SO4 or of any acid? Molecular weight by basicity, just we did in the previous problem. So 98, and what is the basicity of H2SO4? 2. So 49 is the equivalent weight. So I will put 49 over here, and in volume I have already calculated 1 into 10 to the power minus 3, so I can put 10 to the power minus 3 over here. So if I do this, I will get 2 normal. So this was quite easy problem. Only thing that I have to understand over here is this unit. Other than that, everything is given to me actually, and it was very easy to calculate. Okay, we will go for the next problem now. Okay guys, now we will be coming to problem number 88. इसका तो लोग जबरदस्त कॉपी किया है, पूरा प्रॉब्लम ही कॉपी करके छाप दिया विदाउट अंडरस्टैंडिंग इवन an iota of it. Okay, anyhow, now see, in this problem we can see that 1.84 gram per milliliter is given with 98% purity. So we already know how to calculate gram per milliliter to normality. That we already know. So first of all, I will again decipher this 1.84 gram per milliliter. So this 1.84 gram is 98% pure. That is very important in this case. So this basically means 1.84 into 0.98 divided by milliliter gram 100% pure H2SO4. Okay, so basically from this I am getting this much amount of H2SO4 which is 100% pure. So from here I can say the mass is 1.84 into 0.98 gram and the volume is 10 to the power minus 3 liters, because 1 milliliter will be 10 to the power minus 3 liters. Done. Next, from this we are talking about H2SO4. We have already learned the concept of equivalence. So it is preferable to do everything in normality than molarity, because in the second part of the problem I have to calculate for a normal solution. to calculate the volume, let us first calculate the equivalent, then we will see how to come to this. Okay. So, if we see this one, and we have to first calculate over here the normality of the H2SO4 that we have calculated in the last problem also. So, it is not very easy for us because we know the mass, we know the volume, and we also know the equivalent weight of HCl that we have calculated in the last problem. So, let us do this. So, mass is, so this is basically N equivalent by volume in liters. N equivalent is mass by equivalent weight or equivalent mass, volume in liters. So mass is 1.84 into 0.98. This one. Equivalent weight we know it is 49, and the volume I know into the power minus. Here I can write 1.84 into 0.98 into 1000 divided by 40. So this I can simplify 18.4 into 98 after multiplying this by 49. So this will cancel out and I get 36.8 normal of H2SO4. So I have calculated the normality of H2SO4. Now I have to find out what is the amount of this normal H2SO4 required to get this solution. So if I go for number 1 first, it is said 1 liter 0.5 molar H2SO4. Now I have calculated normality over here. I should also think about normality over here. We always have a formula: molarity is equal to 2 into molarity is equal to normality. Normality is equal to 2 into molarity for case of H2SO4. I have said the formula that we have deduced last day was n equal to small n by n. This n was the equivalent factor or the n factor we assume. That for any case what we have to divide over the molecular mass to get the equivalent mass or the equivalent weight that we have considered as n. So here in case of acid, this n factor is basically basicity. So basicity is n. Basicity of H2SO4 is 2. So normality is equal to 2 into n. So what will be the normality of this H2SO4? It will be 2 into 0.5 is equal to 1 normal. Now, now we know that equivalence, number of equivalents of this has to be number of equivalents of the original solution to get the same amount of H2SO4, because we are talking about same compound over here. So number of equivalents in this case will always be equal to number of equivalents in the original H2SO4. So now to use this equation, I had already mentioned in various textbooks. Now you see that N1 V1 is equal to N2 V2. So what is that? Number of equivalents is equal to number of equivalents. That's it. Either in case of neutralization, number of equivalents will be same, or in case of same type of compound, number of equivalents will be same, because number of equivalent will not change with how much water you are putting into it. So number of equivalents will be same irrespective of the dilution of the acid. So abhi dekho, this has a number. I have to calculate the number of equivalents of this. So how do I calculate? I just do n into v. So I just write n1 and v1 in case of this solution. So like this, and this is v1. So 1 into 1 is equal to 1. And let me take this normality of H2SO4 as n into V2. So this is basically N1 into V1 is equal to into V2. So do I know into? Yeah, 36.8. Do I know V2? No. But what will be V2? V2 will be 1 by 36.8. So by doing this one, you will get 0.02717 liters. That is 27.17 milliliter. So you basically require 27.17 milliliter of this acid to make 1 liter of 0.5 molar H2SO. So see how I have proceeded with this one and how you have proceeded in your copy for those who have followed tube solutions. For those who have done it yourselves, good, because this was a good problem. Good. For starting, this was a really good problem. But those who have copied, for them I would say, here I understand everything, but practically saying whatever is given in the solution of KL2, I also don't understand it. It is not clear to me also. But you guys have understood it and done it very well. Neat and clean copy. There is no scratches, nothing wrong about it. Very good. Now in number 2, what is this say? With the same one, I have to form this solution. So what I will do? I will do the same thing again. N1 V1 is equal to N2 V2. So here the normality is 1 and volume is 4 liters. So 1 into 4 into 36.8 into volume I don't know. In this case, the V2 will be 4 by 36.8. So this will come to 0.108 liters. That is 108 milliliter. There is one third problem also, that is also dealing with molarity, so I am not going with that one. So we will go for the next problem right now. We have this out. Okay, our next problem says it is quite similar to the last problem we did, that is problem number 89. It is saying again 1.84 gram per milliliter of H2SO4. Again it is 98%. The problem that has been asked over it is how much of it is required to get 40 gram of pure H2SO. Okay. So from this one we had already calculated the normality is 36.8 normal. That we know. So the normality of the acid is known to me. Only thing that I have to know over here is how to calculate the volume. That I have to know. So number of equivalents by volume in liters. Okay. So first of all, again by the same methodology, I will go N1 into V1 will be the number of equivalents. So here I know the N1, that is 36.8 normal. V1 I don't know. This will be equal to the number of equivalents. So how do I calculate the number of equivalents over here? I already have the mass of 40 gram of pure H2SO. So it will be 40. And what is the formula of number of equivalents? Mass by equivalent mass. Equivalent weight of H2SO is 49. We have calculated so many times. So from here I can calculate the volume. Very easy. And you will get your answer as it is given in the book. Okay, it is given in milliliter. So here from here we will get it like this, 0.022 liter. So this will be around 22.2 milliliter. Right. This is again a very easy problem. Okay. Now this one is a problem that we will discuss right now is on molality. So molality is nothing. It is another measure of measuring the concentration of a solution. So we will first go into the formula of molality. It is equal to number of moles by weight of solvent in kg. So first time the denominator is the weight and the denominator involves only solvent and not solution. So this concept of molality is not temperature pressure dependent. Because number of moles is not temperature pressure dependent, weight of solvent is not temperature and pressure dependent. Please remember, molality is not temperature or pressure dependent. Now let us come to the problem. That's what you have to know about molality. The basic concept of molality is this: that how much number of moles of a solute is dissolved in 1 kg of solvent only, not solution. Molarity and normality both were having the concept of solution in the denominator, but if you come to molality, the concept is weight of solvent in the denominator. So let us find out this problem. This is very easy, direct problem. Directly it is given everything. 1.6 molal, we call it molal solution. This M is molal. Okay. Now number of moles we don't know. Let's keep it number of moles. Weight of solvent in kg. It has been said weight of solvent how much it is. So it becomes much easier now. So number of moles over here is 4. We have to calculate how many grams of acetone. So कितना मोल है acetone का? 4 moles. We will just go by mole concept. We have calculated